Okay, this lecture is on IFDAT. It says if we shall stand still and fear our motion will be mocked or carped at, we should take root here where we sit, or sit state statues only by William Shakespeare. So we're really looking at motion in this case, and what we're trying to do in this particular lecture is we want to know what our learning goals are. Now our learning goals in this case are we want to determine which of the kinematics motion equations we're supposed to use. So far we've learned 4, and the question is, okay, well, how do we decide which one to use in any particular situation? And in order to do that, we need to recognize the connectivity of acceleration, or A, velocity, which is VI and VF, time, which is delta T, and displacement, which is delta D. There's a connectivity between all those variables. So we need to be able to do that. So let's take a look at it as we go through here. And you see the motion equations. These are all 4 of them. If you look, every single one of these variables is missing one particular variable. If you look, this one right here does not have acceleration in it. This one right here does not have final velocity in it. This one right here does not have displacement in it, and this one right here does not have time in it. So that right there is the key to these particular questions, is finding which variable is not in the equation. Because if I have final velocity, why would I use the equation that's missing final velocity? That's taking a given piece of information away. So identifying what you have and what you don't have is the key to these particular questions. So like we say here, we say that each variable or each equation is missing one variable. And you see that in this chart right here. This chart is really something that you should know. So if you look, the only one that doesn't have something missing is initial velocity. If you don't have initial velocity, you have to calculate it. That's a key. So if you're missing initial velocity and it's asking for initial velocity, obviously you solve for it. But if it's asking for something else, you're going to have to solve for initial velocity. Sometimes that's a key to a 2-step problem. Okay, you have to have initial velocity. All these other equations have it in them. So if you look, every other equation is missing a different variable. F, or final velocity, is missing this right here. Displacement, there's no displacement in this equation, and so on and so on and so on. But each one of these equations is missing one variable. So as we flip through it, here's how we pick the right equation. This is a very, very, very important thing. So the first thing that you want to do is read the problem and circle what you are trying to find and underline key information. So if you look right here, how long, okay, could have 2 connotations. It could be how long is the car in motion, or it could say how long will it take. So in this case, how long will it take implies that we're talking about time. So I'm trying to solve for time. Okay. Initially at rest tells me something, can be accelerated from to 60 meters per second in 100 meters. So there's different pieces of information that work depending on what you've got. So it's really important to be able to underline what you do have. So now we pick the right equation. We assign each piece of information a variable. So if we look right here, we go back and we say, okay, 60 meters per second. That was a velocity. Well, which velocity is it? It could be initial velocity or it could be final velocity. Well, it turns out that in this case, it starts from rest, so that tells me how fast I'm going to begin with, and it goes to 60 meters per second, so that tells me how fast I end at. So the key thing is trying to figure out what you're missing here. And so if you look, it says pick the right equation. Determine what you do not have and are not looking for. So we're missing acceleration, and we don't really care what acceleration is. If you look, when we go back to our original question, I don't care what acceleration is. I'm not looking for acceleration. But I am trying to solve for time. And I have initial velocity, final velocity, and displacement. If you see, units are really key here. Match up meters with displacement, meters per second with velocity, and the term rest with the velocity as well. So the key to this thing is finding out which variable you do not have, okay, and then using that equation that is not using the variable that doesn't have it in that equation. So we have IFDAT. We simplified this to the process of IFDAT. We say that the 5 kinematics motion variables are initial velocity, final velocity, displacement, acceleration, and time. And so when you do is when you're solving all these kinematic motion equations, you can say IFDAT. And you start off by saying, okay, I've got initial velocity and final velocity and acceleration, and I'm trying to solve for displacement. So that means I pick the equation that doesn't have time in it, because I really don't care what time is. And then I can go back to my equation sheet and I can say, okay, which one of these doesn't have time in it? Well, the one that doesn't have time in it is now this one right here. So you can do that from rest. Remember, rest is one of those key terms we want to know. Remember, rest indicates the initial velocity is 0 to 44 miles per hour. Now remember, units are key. Miles per hour is an indication of velocity. In this case, since I already know the initial velocity, I know it has to be the final velocity. And then we say in 40 meters. 40 meters has to be a displacement, because displacement is the only thing that we have that's measured in the meters. It says accelerates from rest to 44 miles per hour in 40 meters, and then continues at 44 miles per hour for the rest of the 100-meter race. How long will it take Usain Bolt to finish this race? Okay, in this question we're looking at Usain Bolt, and we're looking at his acceleration in the 100. So first of all, he goes 100 total meters is what he travels, but he does it in 2 segments. It says in the first segment he's traveling 40 meters, and that's the segment that he accelerates in. And then there's a second segment, which is 60 meters, that he's actually traveling at constant velocity in, because he stays at that constant 44 miles per hour. And we want to know what the total time it's going to take him to travel this displacement. So we know he starts at rest, and we know that right here he's going to be traveling 44 miles per hour. So let's take a look and let's assign everything variables. We know we're going to divide this question up into 2 basic problems. So we're going to start off with the accelerated motion. We're going to say, yeah, he starts at rest. We know that the displacement during the acceleration is 40 meters. We know that his final velocity is 44 miles per hour. Now you should know that miles per hour needs to be converted, so we say 44 miles per hour. And we say 1 mile is 1,600 meters. 100 meters. And we say that 1 hour is 3,600 seconds. When you do this conversion, you end up with a velocity of 19.7 meters per second. Okay, so that's our final velocity there. Now, remember that our final velocity for the accelerated motion is our velocity. We're going to change colors just to make it easier to see. Our velocity is 19.7 meters per second. Now, that's for the entire trip. Now, remember, if he travels 40 meters to begin with, that means he still has another 60 meters to travel at this constant velocity. So, remember, we are trying to solve. We are trying to solve for our time, our total time. And our principle that we're going to use is IFDAT, but we're also going to use a little bit of constant velocity. So now, in order to determine the formula that we're going to use, let's look at what we have and what we're trying to solve for. So, we have initial velocity. We have displacement. We have final velocity. And we are trying to solve for time. So the one that I don't have or care about is actually acceleration. So I would go and I would say, okay, which one of these variables or which one of these equations does not have constant, or which one of them doesn't have acceleration? In the equation that doesn't have acceleration, it is delta D equals 1/2 VF plus VI T. But I also have to use the constant velocity equation, and the constant velocity equation is V equals delta D over T. So we've got to actually use both of those equations in this case. So we're going to start off once again with the accelerated motion. We're going to say, okay, 40 meters, 1/2. The initial velocity was 0. The final velocity was 19.7, and we can solve for t. So you can take 1/2 and multiply it by 19.7, or I like to multiply both sides by 2. You get 80 equals 19.7 t. Because 0 plus 19.7 is 19.7, and then you have t. Divide both sides by 19.7, and what you get is you get a total time of 4.06 seconds. Now remember, that's the time that it takes for him to actually accelerate. So if we go back to our original drawing, that's this right here. That's the 4.06 seconds. So now let's take a look and let's see if we can solve for the time that it takes for him to, when he's moving at a constant velocity. Now remember, he actually has to travel further when he's moving at a constant velocity, but he's at that 19.7 already, and he stays that the entire trip. So 19.7 equals 60 over t. Rearrange, so you switch these two, and you get t equals 60 over 19.7. Take those and divide them out, and when you get that, you get a total of 3.05 seconds. Now, remember, if we're looking for the overall trip here, we need to take the two times and add them together, because remember, he's running 100 meters, not just 40 and not just 60. So when we want our final answer, we're actually going to have to take those two answers, and we're going to have to add them together. So, we have our time, which is our answer. We'll go ahead and put it in green just so it's different. Time is going to equal 4.06 plus 3.05, or 7.11 seconds. So we do the same thing in this particular question. We say, okay, what do we know? So we look and we say a jet fighter takes off on a 120-meter runway. 120 meters means we have to be talking about displacement. The plane starts from rest, that's a key term saying that's the initial velocity of 0, and accelerates from 3.4 seconds. So that means that this right here has to indicate a time. So what is the acceleration of the jet? And we will be trying to solve for A. So at this point, you start off with the idea we have initial, final, displacement, acceleration, and time. Okay, you should be able to solve this one on your own. Remember to pick the correct equation using IFDAT. Now remember, this is a vertical motion question, so there's hidden information in this particular question.